I know this to be an n-shaped function. How do you know this is an n-shaped function? Yeah, it's a minus x squared. So look, if I can quickly throw this in here, just get a quick gist of what it looks like. Okay, it doesn't have to be a master class. It just has to be roughly. You might know where the biggest point is. I'm going to start at -5 and end at +5. The points, I'm thinking it crosses the axis at 0, 0. Fair enough. All right, and then it seems to reach a maximum at 1, 1. Ever see 1, 1? Okay, then what happens after 1, 1? Yeah, the maximum isn't actually at 1, 1, but it appears to be at 1, 1. Okay, so your function looks something like this. Everybody agreed? Now, so when the slope is on its way up, so if you remember when you play Super Mario, okay, when you play Super Mario, you go left to right. When you go up a hill, it's a positive slope. When you go down a hill, it's a negative slope. Up a slope is increasing, down a slope is decreasing. Ever cool with that? When moving left to right. So what I have here is we'll have the increase in here, and it stops somewhere up here, and then it's decreasing in the blue zone. Now I need to find the point at which it's stationary. Do you get what I'm saying? I need to find the part where it's flat, where the slope equals 0. Now, in differentiation, the first derivative is the slope. So I'm going to differentiate this once. What happens when I differentiate it once? 4 minus 6x, is it? Right, 4 minus 6x, and I want the slope to be equal to 0. Then I get 4 equals 6x, and then x equals 2 over 3. Now, if you aren't sure about this, here's what I recommend you do. Go back to your table function, all right, and do what's called it's almost like you're zooming in. So go back to your function, and instead of doing it from 5 minus 5 to 5, what I suggest is you go from 0 to 1, do a step of 0.1, and you can verify what you just saw. Look at the y values. When is the y value at its biggest? Keep going. Keep going. 0.6, it's pretty big, isn't it? And then 0.7, it's 0.33. And then it goes back down again, doesn't it? So we know that the maximum value is at this point 0.67. If you get what I'm saying. So we want everything to the left of this value. So what's to the left of this value? X smaller than 2/3. Everybody cool with that? Who got that one out last night? Something like that. Good job, alright. You happy enough with that? So next one we'll do is a U-shaped function. And this one, once again, it's a U-shaped function because it's a plus x squared. I have no idea really where it's going to land. It could be like this. It could be down here. It could be over here. I don't really know. But what I do know is that I'm looking for when the slope becomes 0. So slope is equal to 0. So first derivative is going to be 6x plus 8. Slope is equal to 0. 6x equals minus 8. X equals minus 8 over 6, which is minus 4 over 3. That means the minimum point occurs in the negative x region. And the negative x region is over here. Is that right? So, what I'm trying to figure out is, do I want the values to the right or to the left of that point? Hey, then what do you think? It's increasing, so you want to be going up a hill, not down a hill. So if you're going up the hill, it's to the right. Give it a second. Alright, if you're going up a hill, it's to the right, so it looks like that. Cool. And that means that x will be bigger than minus 4 over 3, to the right of it. Right, drive on. Drive on. Alright, next one. show that this is always increasing. Now, at a glance on your calculator, once again, this can explain a lot to you. You just lob this in, and what I'm expecting to happen is that the y values will always get bigger, and they'll never, ever, ever get smaller. Okay? So, oh dear. So, I'll go from -10 up to +10. Looks like a decent range of values. And we'll see if anything happens. So, -10 up to +10. Step of 1. Now, you don't have to do this. This just explaining it to you. See, the y value is really, really, really negative. Yeah? So the y value is really, really far down. Okay? And what happens is it keeps going upwards. And it crosses at 0,4. So it comes up and it crosses at 0,4. It starts off steeper because it's jumping up quicker. And now it stops at 0,4. Now you keep going. Then it goes up to 117, 224, 321. It's getting bigger again. So it almost does something like this. And then it just keeps going up. There is no up and down. It's just constantly going upwards. Now we have to prove that it's constantly going upwards. Okay? And here's how we do this. First derivative. What's that mean? 3x squared, yeah. Minus 12x plus 18. Now, we would have remembered something back in the day called completing the square. Okay? We would have done it a while ago. So let's figure out this. Let's make things easier on ourselves. Divide by 3. What do we get? X squared minus 6x plus. Anybody? What? Oh, sorry, 4x. And what's the other one? 6, isn't it? Now, here's what I want you guys to look at. I want you guys to zone in on this part here. And you remember how to complete a square like that. You half the middle value. What happens when you half the middle value? What you get when you half the middle value? What's x minus 2 squared when you multiply it back out again? Plus 4. Okay. Now, what's the issue here? Now, if I sub in, if I replace this, yeah? If I was to replace this with a perfect square like so, okay? What's the issue when I multiply that back out again? We'll find out in a second. It's going to be 3 times x squared minus 4x plus 4, which is 3x squared minus 12x plus 12. How much am I short? I'm short. And then we put the 6 at the end. Alright? If you're really unsure on how to do these, so your formula is a perfect square. It's 3 times a positive number plus 6. And that will always be bigger than 0. So it's 3 times a guaranteed positive number plus 6, which is always greater than 0. This means your slope is always greater than 0. This means your slope is always pointing upwards. Hill. If you guys are struggling with this, I suggest exercise 2.6, and you can see on my YouTube channel there'll be a few of those there as well. Alright, let's move on. So, a trail over a mountain pass can be modeled by the curve with the equation y equals 2 plus 0.12x. So it's basically describing something like this, where it's like a function. Imagine that's the top of the mountain, and it describes your walk, like whether you're gaining altitude or you're going back downhill or whether you're going back uphill. It's basically like a mountain walk, okay? If you're ascending, your slope is positive. If you're descending, your slope is negative. Stuff like that, okay? Now, it says that it's only between 0 and 3. So they're the only valued parts, okay? So if you went to your table function and you did 2 plus 0.12x minus 0.01x cubed. You get a quick idea for what they're trying to explain to you. Start at 0, end at 3. I don't think I'll get away with step of 0.1, so I'll go for step of 0.2. And look what's explaining. At the beginning of your, I think it's in kilometers, is it? It's in kilometers. At the beginning of your trail, you're 2 kilometers in altitude. After doing 1 kilometer of horizontal walking, you're now at an altitude of 2.11. Then you sort of reach a maximum height. At 2 kilometers, you reach a maximum height of 2.16. You're up the hill, and now you're on your way back down again. Is that right? So that's the basic premise of the question. You're going up a hill, and then you're going back down again. Now, find the gradients at the beginning and end. Gradient means the slope. How difficult is the slope at the beginning of the trail? So what's the slope in differentiation, Charlie? First derivative. Let's just get the first derivative. And we get 0.12. And we get multiply that by 3, so 0.03 x squared. Next thing we're going to do is, it's the beginning of the trail, so what's the x value? 0. The x value is 0. So I think the slope is going to be 0.12. Okay? What does 0.12 mean? For every 1 kilometer you walk across, you're only going to ascend 0.12. Does that make sense? For every 1 kilometer you walk to the right, you're only going to go upwards 0.12 of a kilometer. Everybody cool with that? Now that's consistent with our calculator, where our calculator is shown it's shown that we're ascending. Ascending means that you're gaining altitude, which means a positive slope. At the end of the trail, are we on our way up or on our way down? We're on our way down, so I'm expecting a negative slope here. Let's find out. So the first derivative is 0.12 minus 0.03 x squared. Now the x value this time is going to be 3. And it's going to be 0.12. Whoa, I think we made a mistake. Oh, sorry, 3 squared. There we go. 0.12 minus 0.27 minus 0.15. This means at the end of the trail, for every 1 kilometer you go across, you're going to descend 0.15 because you're on your way down. Hope that makes perfect sense, does it? Right. Calculate the point at which the gradient is 0. When are you at the top of the mountain, and when does the slope become 0? That moment you're at the top of the mountain and you're not going up or down. So what do we do this time? Put it equal to 0. So put the first derivative equal to 0 and solve. So what I'm going to get is 0.12 equals 0.03 x squared divided by 0.03. You're going to get 4. 4 equals x squared. X equals plus or minus 2. Why is that not allowed to be minus 2? That's your reason. Has to be between 0 and 3. Does the value of 2 correspond to what our calculator told us? Is 2 the highest point in the question? Gets smaller either side. So that would be affirm. Yes, it is the tallest point in the question. Okay, let's move on. 24. Alright, I'm gonna be quiet for a minute. You guys go for it yourselves. Go. Alright. So what we're hoping you remember is that when any line or curve crosses the x-axis, the y value is guaranteed to be 0. And when any line crosses the y-axis, the x value is guaranteed to be 0. Okay? So what we do first is we get this equation, which is y equals square root of x plus 2. And what we do is we sub in x equals 0. So this means y will equal root 2. That means this point here is going to be, this point here is 0 root 2. Then we go for where it crosses the x-axis, and where it crosses the x-axis, the y value has to equal 0. So 0 equals square root of x plus 2. This implies that x must equal minus 2. So oddly enough, it's over here. And there's your 2 points. Minus 2, 0, and 0 root 2. That's A, and the red one is B. Next thing we're going to do is differentiate using the chain rule. This will give us the slope formula at any given point. So you change y equals x plus 2 to the power of a half. Daily, what you do next? Bring the half to the front. And what you do to the power? Minus 1, which would be minus a half. Yeah. And then differentiate the chain part. 1, which you don't need to put in. We cool with that? Now, we've done part A, we've done part B. Now we're on to C part 1. Now, in C part 1, what we're asked to do is find the slope when the x value is minus 1. No bother. So C part 1, get your derivative and replace in x equals minus 1. So you're going to get a half minus 1 plus 2 to the power of minus a half. Anybody got a slope of a half? Can you throw it in? Slope or gradient equals a half. Part 2. Find the equation of the tangents. So if you imagine a curve here, I don't know what way the curve actually looks, but imagine some sort of curve here. Okay? And there's some point at minus 1, which we call the green point. And what you want to do is you want to find the tangent at the green point. And the tangent will be a straight line. Well, the tangent is a straight line that goes through the green point. How would you get a tangent mark straight away? What would you write down? Y minus y1 equals m into x minus x1. Tangent is a straight line. What point does the tangent go through? We know it goes through the point minus 1. But we don't know we don't know the y value, do we? How'd you find the y value, Heyman? Go back to the original formula and replace x with minus 1. And you end up getting y equals 1. Now you know your point is minus 1, 1. Heyman, what's the slope at this point? Okay? A half, exactly. So now you're at y minus 1 equals a half into x plus 1. 2y minus 2 equals x plus 1. Minus x plus 2y minus 3 equals 0. Who got that? Right, good job. Alright. If the tangent meets the x-axis at C and the y-axis at D, calculate the length of CD. This is a great old question. Now, what you have here is your xy axis, and you have this equation here. And this line has a slope of a half, and what happens is it intercepts the x-axis at C and the y-axis at D. So you're C and you're D. Now once again, at point D the x value is 0, and at point C the y value is 0. So let's figure that out. x value equals 0, we're going to get 2y minus 3 equals 0. Then we're going to get 2y equals 3, y equals 3 over 2. The point D is 0, 3 over 2. The point C is where y equals 0, so we're going to get minus x minus 3 equals 0. Then we're going to get x equals minus 3. This makes the point C minus 3, 0. Anybody know how to get CD? Distance formula? A lot of revision in this one. Okay. And what do we get? Done, fail. What you get? Alright. 9 plus 9 over 4. Root answer. And in decimals, 3.35. Alright. I'm going to save this video. You guys have a read of the introduction to the next exercise. Quite easy, I assure you.